We're now going to look at measures of variation. Okay, so these are numbers that are going to describe kind of how much the data varies, or maybe how spread out the data is. And so I want to give an example here of a very simple, let me write it down here. So the range is just the maximum value minus the minimum value. And so let me give you an example here. This would be a very simple measure of variation, or measure of spread. Okay, so let's say I have a data set. Maybe it looks like this. And we can say that this minimum value, let's just say this is like 35, and this maximum value here is 65. And here in the center, we have a mean that's equal to 50. Okay, and I want to know how spread out is this data set. So I can calculate the range. And the range would just be the maximum value minus the minimum value. And I'd get a range of 30. Okay, and that would give us kind of a measure of how spread out the data set is. From the smallest to the largest value is 30. And so that is a very simple measure of variation. But it's not the best measure of variation. And the reason for that is it's only taking into account the minimum and maximum values. So all the other values in the data set could be doing something different. So for example, maybe I have a data set that looks like this. Maybe the minimum value, we'll say again, is 35, and the maximum value is 65. Okay, and we'll say that the mean here again is 50. Okay, and so I want to know how spread out is this data set. Well, the range in this case is still going to be 65 minus 35. And that gives me a range of 30. So it has the same mean, same range, but yet this is a very different data set. And in particular, this data set kind of has all the data here in the middle, close to the mean, and then as you get more spread out, there's less and less data. Okay, while this one, there's barely any data close to the mean. All the values are spread out to the end, into the edges of the data set. So this, in a sense, is more spread out. Okay, and so this one, even though they have the same range, this one, in a sense, should have more variation or more spread. But the range doesn't catch it because it only takes into account the minimum and maximum values. So what we want is a measure of variation that takes into account every value in the data set. And that measure of variation is the standard deviation. Okay? So let's write that down. So the standard deviation this is a measure of variation that takes into account every value in the data set. Okay, so how's it going to do this? Well, the way that it's going to do this is it's going to find how much the different values deviate from the mean. Because this one's more spread out because the values are further out from the mean, while here they're really close to the mean. Okay, so the standard deviation is going to kind of be, in a sense, almost the average, like on average, how far do the values deviate from the mean. And so a single deviation can be thought of like this. So let's say here's the mean, and it's equal to 50, right? And then here is a value. We'll say it's 42. That's one x value. And let's say I got another x value up here, and we'll say that's 63 or something like that. So you got these different x values. So how far do these deviate from the mean? Well, this one up here, this would be 63 minus 50, and this one is like 13 units from above the mean, right? Well, what about this one here? So the distance from here to here, again, I'll take the x value minus the mean, and what you see here is that you get a negative 8. So it's negative because the value is below the mean. In this case, it's positive because it's above the mean. So 42 is 8 below the mean. 63 is 13 above the mean. And so a deviation here, if I were to come up with a formula for a single deviation, a deviation is just going to be the x value minus the mean. And for every value in the data set, I could get a deviation, right? And then I'd have all these deviations, and then in a sense, the standard deviation is like taking all those deviations and averaging them out. But it's not quite just an average, okay? It's a little different than that. And so let me give you the formula for that, and in the next video, I'm going to teach you how to calculate the standard deviation. Okay? So what I'm actually going to teach you here is known as the definition formula for the sample standard deviation. So this is the definition formula. In another set of videos, I'm going to teach you the computation formula for calculating the sample standard deviation. But first, we're going to learn this formula, and this is the definition formula for the sample standard deviation. So we're going to let x bar be the mean of a sample of size n, then the sample standard deviation is given by the following formula. We're going to use S. S denotes the sample standard deviation. So S for sample standard deviation. And it's going to be the sum of x minus x bar, that quantity squared, all divided by n minus 1. And then we're going to take the square root of that, just like that. And this is the formula for sample standard deviation. Now I know it looks a little confusing. It's not clear exactly how we calculate this. One thing you do see is you see that deviation there. So it looks like you're going to take these deviations, you're going to square them, you're going to add those all together, then you divide by n minus 1, and you take the square root. In the next video, I'll give you a nice, easy way of how to do this.